Okay, good afternoon. So today we'll be talking a little bit on the enterprise side. So the title is Can High Performance Interconnect Benefit Memcached and Hadoop? So this will be co-presented by myself and Santhan, who is sitting there. So broadly, I'll just quickly go over some introduction and overview of Memcached and Hadoop if some of you are not familiar with, and then try to show some new approach towards having a very high-performance implementation of this Memcached and Hadoop in the OFA environment, and we'll be trying to show you some numbers. So now, as we have been hearing, I mean, since yesterday, and if you think of like the OpenIB started almost, 2003, almost 8 years back. So both InfiniBand and 10 gig, I mean, at that time, it was totally new, saying, okay, how do we take advantage of that in the HPC? But I think we have already come far away along that direction. We give very good latency, bandwidth, also low CPU overhead, and especially Open Fabrics has been quite successful. There are a lot of machines in the top 500 list. But now, from the last few years, there is a lot of interest coming up saying, how do we take these kind of ideas and then try to approach it into the, or apply into the enterprise domain. And we heard that from the Google keynote talk, Oracle talk also, we saw that InfiniBand is being used, same in from the IBM talk. But the main thing, in a general manner, if we want to push InfiniBand or Open Fabrics to the enterprise domain, performance still remains a big concern, performance and scalability. So here are some of the numbers, like if you think of like our MPI over the years, like we have been able to deliver, like this is on a 2.4 gigahertz system, like a 1.51 microsecond latency, and bandwidth here, this is on a Nehalem system, we come close to 3 gigabytes per second. If you do like a Westmere platform, we go up to 3.5 gigabytes per second. So the question is, if we have done this for the MPI, why can't we do it for others? Like take any other component, we should be able to deliver similar performance because these components can again run over InfiniBand or OFA Verbs layer in a bare metal performance manner. So if you think of very generic software ecosystem in the cloud and see the challenges, so we have a Memcached component, which is typically used for scalable distributed caching, widely adopted caching front end for MySQL, other databases, and we have been like MapReduce also is being used by a lot of people. It's a scalable model to process petabytes of data, and especially Hadoop MapReduce framework is widely used. But these are so far these designs are still sockets based. So the sockets API itself, even though it allows a lot of portability and all, but it doesn't deliver you the performance. And the sockets API were designed like almost decades ago. And at the same time, we are also seeing a revolution on the storage side, like especially the SSDs are trying to improve the I/O characteristics. The Google keynote talk highlighted this. So gradually what is happening, earlier I/O used to be the big bottleneck, and the I/O costs are coming down. So then gradually you will see that the communication costs are becoming much more dominant. And then if we can handle that, then we'll be able to design a very balanced system. So the question here we are asking, can OFA help the cloud computing software performance? So this just quickly shows the differences. Of course, this is a compute cluster. We have a bunch of nodes connected with high-performance interconnect. So the system design is interconnect-centric. But as we heard from a lot of talks today, the cloud computing environment has very complex software. I mean, so we have a set of nodes, local storage, then we have the virtual file system, and here we have several VMs running. So we have to make sure that all these components can work together and trying to harness the performance. So let's quickly go over the Memcached architecture if some of you are not familiar. So this is like a typical the internet data center kind of thing. So we have from the internet, request can come to the web front-end servers, and then these are the Memcached servers. So what do the Memcached servers do? They basically, it is a distributed caching layer. It allows to aggregate spare memory from multiple nodes. So you can take the memory from each of the nodes and come up with a big amount of memory space, and this can be used as a general purpose manner. And then here we have the database servers. And this memory can now be used to cache database queries or results of the API calls. So this is a good scalable model, but the typical usage is very network intensive, because these are the nodes which are connected with some system area network, so all those communications will go over that network. Similarly, Hadoop is like this is the generic architecture for Hadoop. The underlying is the Hadoop distributed file systems, or called HDFS. So there is a built-in fault tolerance by replicating the data blocks. And there are typically a name node which stores the information on the data blocks. There are a bunch of data nodes which store the blocks and host the map-reduced computation. And then there is a job tracker which tracks the jobs and detects the failures. So here again, this is a scalable model. You can keep on adding a lot of data nodes. But once the communication starts, there is a huge amount of communication takes place during these intermediate phases. And at that time, we will see that depending on what kind of file systems you use and whether it is a disk drive or it is the SSDs, you will see different kinds of performance and scalability. We'll show some numbers here. So broadly, over the years, if you see, like, this is a very short summary. We started with InfiniBand 10 years back. Then the iWork came into the picture. So there has already convergence happened with Open Fabrics. All of you know about that, so I don't want to go over the details. But that has led to a lot of choices in the protocols. So let's see all those things. So let's say you have an application. So very simple thing is it can use sockets, and then you go through the typical, like, a TCP/IP with Ethernet driver, and then it runs on some 1 or 10 gig adapter. So this is one approach. We'll see that the native approach, a lot of systems applications use. So in fact, currently the Memcached and Hadoop, they actually use this environment. But there is a choice here. We see that the TCP/IP can now be mapped to IP over IB, InfiniBand adapter, and then it can go to the InfiniBand switch. So this is the second kind of interconnect protocol combination, IP over IB, and a lot of stacks also use that. The third one is you take the TCP/IP through hardware offload and then go through the 10 gig adapter. So here we'll call this as a 10 gig TOW, like the Chelsea adapter kind of thing. So that is a third option for you to use for your application. But please note that all of these are going through the sockets. So that is kind of application goes through sockets. Then you have all these three choices. And you can also have the fourth choice, which is the same sockets. You take it through SDP, and then the SDP uses the RDMA functionalities, and then it can run with InfiniBand adapter and the InfiniBand switch. So this is the SDP. And finally, if you don't want to go through sockets at all, then you can directly go through the Verbs. And then from the Verbs, you can go through the RDMA and InfiniBand adapter. So this is actually the extreme which has been used in all the MPI stacks over the years. So that's how you get the performance. So now you don't get the performance from these alternatives. You always go on to the rightmost. And then your application is directly, like, application here is MPI, like a library, and then that is directly coded with Verbs, and then it goes over InfiniBand, and you get those kind of best performance. So the question is, can we actually move to that side? People are here, and can we move to this side and see how much benefits happen? Okay? Are there any questions here, like the overall picture? So keeping this kind of background in mind, now let's see what is happening in the cloud environment. So the current cloud software design is broadly, again, if you take the similar kind of picture, we have applications. They are trying to utilize sockets and then trying to go through 1 or 10 gig network. And in some of the talks, we also heard about accelerated sockets. So people are trying to enhance the performance of the sockets. Then it can actually use the Verbs or hardware offload. But if you take a closer look, sockets you can still accelerate it, but sockets are not designed for high performance. And there is a inherent mismatch in the sense sockets have the stream semantics. So if you take like a Memcached or Hadoop, you will see often there is a mismatch here. Okay? So even though you can add some more additional blocks and accelerate, but you are not bridging the gap completely. And especially even some of the stacks, like you have zero copy, but the zero copy is not available for non-blocking sockets, which like Memcached uses. So now the question is what we are trying to propose here. Our approach is, again, go to the right extreme from the previous slide, so that if there is an application, can we directly take it to the Verbs, and then it can actually try to utilize the OFA interface over is a 10 gig or InfiniBand, then we should be able to take the complete performance. So if we can do like that for some of the major components, especially here I'll try to show you for some of the results on the Memcached and then some of the things on the HDFS. So if you can keep along those lines, then you will see that we can have some significant consolidation, and especially the Hadoop and Memcached are developer-facing APIs, not sockets. And if we can improve the basic Hadoop and Memcached, immediately you will see benefit for many other applications, and that is the kind of approach what we are taking currently. So this is a very high-level picture of the Memcached we have done. Now, once you start looking at the Memcached, there are two components. There is a client component, there is a server component. So you can always try to come up with a better server, but you are not very sure whether your clients are RDMA capable or not. Okay, so what we have done is, we have done this is a bigger architecture, like the Memcached uses some concepts of shared data called memory slabs, if some of you are familiar. So then we have introduced two different kinds of worker thread. So these worker threads might be a sockets worker thread. They are meant for the clients which are older clients. They are only sockets capable. But on the other hand, we have also introduced some Verbs worker threads. So these are the advanced worker threads and lightweight, and then they can actually communicate with the RDMA client. And then we have a master thread, and we also have a negotiation protocol, so that depending on the client's behavior, you come to the master thread, and the master thread knows that, yeah, now I have an RDMA client, so I should try to assign it into a Verbs worker thread. Okay, so that that communication can get the best performance. On the other hand, if the client is sockets, then they will be getting assigned to a sockets worker thread. And once the client is assigned to a Verbs worker thread, it can actually communicate directly and is bound to that thread for the entire transaction. Okay, so it is not moving around. And the other important thing is that the Memcached data structures are shared among the RDMA and the sockets worker thread. So we are not separating or duplicating any resources, but they are trying to utilize the same shared structure. In fact, they also use, just like the talk I presented yesterday, like MPI and PGAS, or MPI and UPC, the same concepts also gets used here. So inside the runtime, they are actually utilizing all the same resources. We are not separating any based on the different kinds of worker threads. So this is a very high-level design. So now I'll hand it over to Santhan. He will go over some of the results, what we are getting with the latest versions.
Hello. Yeah. So I'll be presenting some of the experimental numbers which we have seen with our prototypes. So our experimental setup consists of two different types of clusters. So the first one is a slightly older cluster of Intel Clovertown, and it has InfiniBand DDR. And the second cluster has InfiniBand QDR with Intel Westmere, and that's like more of a leading edge kind of platform. And we have used the Memcached server version 1.5 and the client version 0.45. And we have actually made the modifications based on those versions. And for the Hadoop experiments, we've used the same two clusters, like the first cluster, and then we've actually used the Intel SSD on some of the nodes. And we have used actually unmodified Hadoop for our experiments with the Sun Oracle version of Java. So first, we are taking a look at some of the Memcached numbers. Here in this experiment, what's happening is you have one server and you have one client, and each client is trying to do a get of a particular size of request. And here we want to quickly see, like, what is the impact of going to Verbs? What type of performance you can actually expect? So in fact, we see a very good performance improvement. So for a 4-byte Memcached get, for DDR we can get it down to 6 microseconds, and for QDR we can get it down to 5 microseconds. This is a round trip, I should remind you. It's not one-sided, so MPI numbers are one-sided. This is actually a two-sided with some lookup on the remote side. So this is actually close to what we expect if you do the analytical modeling. And for the 4K byte request, which is supposedly a very important number for like Memcached users, because many of these objects are of that size, we can get it down to 12 microseconds for QDR. And it's almost a factor of 4 improvement over like the 10G TOE approach for the 4K. So that's this number, which you can see here. It's a very big improvement, and and most of these improvements come from the fact that it's like OS bypass, user level protocol, and so on. So we expect that iWarp will also have some improvements, and we are in the process of evaluating this with iWarp as well. But for the first cut, we have just gone to verbs. So now we want to go into the number of transactions per second. So this is where the scalability comes into point. Like what happens when you have many servers, clients just hitting one server? Like can you improve the throughput, so to speak? And if you see the Memcached transactions for 4 bytes, on IB QDR, you can almost go up to 2 million per second, and that is like factor of 6 improvement over SDP. And this is again showing the like you can push the envelope of performance significantly if you go to verbs. And again, we are in the process of evaluating iWarp and 10 gigabit Ethernet. Okay, so now we'll move to the Hadoop experiments. So as I mentioned before, that these experiments are with unmodified Hadoop. So the first thing we want to understand is that HDFS and the entire Hadoop framework is in Java, right? So is there any performance penalty by going to Java, right? That's the first thing which we hear. So we wanted to probe a little bit, and I see several people in this room are aware of our OSU micro benchmarks where we do ping pong and bandwidth. So we thought that why not create such a benchmark for Java as well, and let's try to do some competition between C and Java and see basically if you can improve the Java performance. So we found out that if you use Java NIO, which is the new IO package in Java, and if you use the allocate direct factory method, which is basically bypassing all your like your garbage collected heaps and crap like that, so then you can actually, if you see the blue line, the speaker is blocking my view, but if you see the blue line and the green line, you can see that you can get good performance. So it's not a question of will Java completely kill your performance or not? You can get the performance, but you need to make some adjustments to your Java code to actually deal with RDMA communication. And we note that HDFS does not use this kind of communication technique. So in the future, we are looking towards improving the HDFS Java code itself. And these numbers were published at a workshop with Micro in Atlanta last year. So now we see something even more important. Here we are trying to see the performance of the Hadoop distributed file system. And in this experiment, what's happening is this is like a benchmark which is distributed with Hadoop itself. So the clients will generate like a varying amount of data from 1 gigabyte to 10 gigabytes. And this is written into the distributed file system. And the way the distributed file system works is that for every block you write, it's replicated 3 times. So HDFS follows a pipeline protocol in which these blocks are replicated. So there are a lot of lines, but I want to draw your attention to this line, which says 1G with SSD. So here you see that if you have 1 gigabit Ethernet network, even though your backend storage is SSD, your performance is very similar to that of your hard drive. So you can't even leverage your SSDs very well. But if you see all these HPC networks with SDP, IP over IB, and then you use SSD, then you can see that you can boost your performance a lot. So this actually keys in with the comment a day before from Google that as the I/O performance is improving, it's very important to look at communication, because otherwise you won't be able to exploit your I/O improvements, and that's what the slide is basically saying. Then we are looking at another benchmark called as Hadoop Random Writer, in which each client will generate random amounts of data and dump them into HDFS. And here also we see that even with like 1G SSD, you can improve a little bit. But if you couple SSDs and like 10G SDP IP over IP, then you get a lot of improvement. You can improve almost by 50% for like 1G and about 59% for IP over IP, etc. Now we are looking at the Hadoop sort benchmark, and that's what I think this community is very interested in. They are always running TerraSort and so on. So over here also we see that while the sort phase is I/O bound, we did some internal profiling. Actually, the reduce phase is very communication bound. Right now, in fact, the communication is taking place over HTTP, which is like so many layers above. But even then, putting in SDP can improve the performance significantly by about half. And one can only imagine that if you put a good implementation of verbs here, you could gain factors of improvement, not few percentage, but factors of improvement. So with that, I would like to summarize our talk. So Open Fabrics has come a long way in HPC adoption. It is like dominating the top 500. It has taken over like a big portion of it. But we are now facing new frontiers in the cloud computing domain. And like previous attempts at Open Fabrics adoption have tried to sort of like shoehorn OFA through sockets, but I think it takes away a lot of the performance benefits. And now we are seeing that the cloud ecosystem itself has a standardization. You have the Apache projects and Memcached and so on. So if you take those APIs and you improve the performance of those implementations, then a lot of these applications in the cloud computing domain are going to benefit. And we have shown an example where Open Fabrics can improve HDFS performance and get factors of improvement for Memcached. And we are currently working on the verbs level design of HDFS and HBase. And actually, if you are in the loop, then in fact, Facebook uses HBase, like the open source version of HBase. So if you can improve these things with verbs, then you can have a very big impact. And that's what we are working on. Thanks. Any questions?
Could you go back to your Memcached slide? That up and off like that.
This one?
Yeah. So the factor of 4 is improvement over normal template.
Yeah, that's this. That's this data point.
This one, that is for DDR and QDR also.
Yeah, we didn't have a 10 gigabit setup on our QDR machines. We only had a 10 gigabit setup on the DDR machines.
But there's a V in the curve there. So it's not so bad.
Yeah. Well, we used whatever settings we use for Chelsea or 10 gigabit Ethernet. And in fact, I forgot to mention, in fact, this Memcached, like if you run the Memslap benchmark, by default, you don't even get this performance. You get something which is worse. In fact, we had to change the socket type to use TCP no delay to disable Nagel's algorithm, because by default, Memcached will use UDP. So in fact, we made several efforts to optimize this. This is not the first cut. But I'm sure if you want, you can go ahead and optimize this further. But we made a serious attempt to optimize it. Yes, exactly. So IWAP can show a better number, but we have not done that yet.
Any other questions? Okay, thank you very much, DK.
Thank you.
We'll see you back here in 30 minutes.